we want healthy and resilient cities, we need to understand and properly care for urban nature and the people who rely on it. When we consider the sheer number of trees and other natural infrastructure to manage, the diversity of human populations, and the increasing effects of climate change, you can imagine how difficult it is for city managers and practitioners to make informed decisions with lasting impact. Our system combines data from multiple sensors connected to the 5G network to provide key information to protect and manage nature in our cities to promote resilience. The Natural Assets team is leveraging the Rogers 5G network to pilot solutions and develop a data-driven system for natural asset management in cities. We are an interdisciplinary team led by faculty from Forest Resources Management, Electrical and Computer Engineering, and the Sauder School of Business. Natural assets refer to natural infrastructure in cities, such as trees, parks, green spaces, and other vegetation. Natural assets are also critical. They provide nature-based solutions that can help Canadian municipalities address climate change. Natural assets are also key supports for human health and well-being. To ensure our system is grounded in real-world problems, we conducted 8 interviews. These were with natural asset experts, urban foresters, conservation authority practitioners, and solutions providers to better understand how their organizations work with natural assets. We found that overall, participants outlined 3 main challenge areas: data and technology, institutional and organizational challenges, and societal issues. Within the area of data and technology, some issues include collecting inventories, user uptake, and data standardization. Participants also identified opportunities for technology to address some of these challenges. One interviewee said, "At the end of the day, what we're really trying to uncover is what we call a reference architecture for natural asset management. There's cool opportunities to test new technologies there." Envision a system that can not only identify, monitor, and assess the value of natural assets in cities, but can also generate actionable insights about how natural assets are used by people to evaluate risk and make informed decisions about investment and management. Our system consists of the following main components: ground-based sensors installed in trees and in the soil at the tree base. These are to monitor ecological activity. Aerial-based sensors mounted on an unmanned aerial vehicle, and mobile data acquired from smartphones. These are to monitor both ecological and social activity. In the last 8 months, we've done the following. We are now collecting data on both natural assets and natural asset users, and piloting data processing and analysis techniques to inform our minimum viable product. We installed soil and tree dynamic sensors in 4 tree locations and green spaces on campus. Soil sensors measure soil conditions, while tree dynamic sensors measure the way trees move with wind. These parameters provide us with information to assess tree health in each green space. The locations have natural variability in terms of area size, shading, accessibility to the public, and most notably, the soil type. Before the sensing devices are deployed in the field, quality assurance testing is needed. This includes provisioning boards individually with Azure and InfluxDB. We've also manually soldered and assembled over 60 sensors into 9 sensing devices. One key challenge in natural asset management is collecting information about tree condition across large geographic areas. Yet these datasets are critical for cities to be able to look after their trees over time. They are also important for budgeting future maintenance and planning, as well as calculating metrics for sustainability goals. The UAV we will use to assess vegetation condition is equipped with a multispectral sensor, which can detect and record changes in color in tree leaves that are not visible to the human eye. Since we are using a UAV, we will be able to collect data across a large geographic area much more easily than doing it manually. Finally, data about people from mobile phones can help us understand relationships between the condition of urban trees and human behavior, and infer natural asset use and value. For example, do busy places show greater signs of tree stress? Do people avoid areas of poor tree condition? This demo visualization of simulated mobile phone data shows changes in density patterns of people across the UBC campus over time. We can also overlay this with data collected from the tree and soil sensors, as well as the many other data sources available across the campus. We will supplement the sensor and mobile phone data with information on individual uses and perceptions of natural assets gained from a survey distributed to diverse residents of the City of Vancouver. This will provide insight into why humans choose certain environments and how they perceive the benefits of urban forests and other green infrastructure. Natural assets are critical to cities. Our system will provide managers and practitioners with tools and information to make better decisions in the face of uncertainty. As a partner in this project, Rogers is poised to make substantive contributions to urban resilience and position Canada as a leader in the making of smarter and more sustainable cities.